Hello, today is Alfred Wegener's birthday, and to celebrate this phenomenal day, we're going to go deeply into the evidence of plate tectonics and evidence that backs up Wegener's theory. I am your host, Nikki Shin, coming to you from Germany. Now, this map shows a lot about the continental drift theory. Okay, so first of all, you can see that this is a world map of Earth, and of course it is not as accurate because one, it's not a sphere, and Earth is a sphere, but it still covers most of the evidence that I'm going to be proving to you today. First of all, our first evidence is that if you see the line between Africa and South America, you can see that this actually fits pretty accurately, and it actually fits just like a jigsaw puzzle. That's one of the and this is not just because of a coincidental act, but Wegener has actually proven that all of these continents actually can come together like a jigsaw puzzle and make one big supercontinent named Pangea. The next evidence I have found is fossils, and these continents were actually one big supercontinent. Animals of the same species will usually be next to each other, or at least be in the same kind of land. But if you see in this map here, in South America, there's a fossil named Cygnognathus in South America, but that's also found in Africa as well. How amazing is that? Okay, so these fossils are dead, so they can't move. But how on earth is it possible for them to be separated into two different pieces of land with a South Pacific Ocean in the middle of them? Well, the only explanation for this is that they couldn't have swam, so this is another evidence that supports the continental drift theory. Then there's also the plate boundaries. So, for an example, you can see that this is the North American plate, then this is the Eurasian plate, this is the African plate, this is the South American plate, and last but not least, the Caribbean plate. Of course, these are not all of the plates that Earth has, but these are some of the major plates that Earth has to this day. So, these plates all move because of the intense heat in Earth's core that causes molten magma in the mantle layer to move. You can think of it like this. A paper boat probably goes faster in hot water, and think of hot water as magma. Which brings me to my next topic, seafloor spreading. Seafloor spreading can be also found between South American plate and the African plate. If you see this line that goes right between it, that you may find that there is a ridge. Now this ridge that's between the middle of the South Atlantic Ocean is what causes Africa and South America to never touch again because of that ridge. That ridge is formed by when magma comes out and makes new floor, and then they go apart while making new floor at the same time. Now, one of the major evidence I have found is convection currents. Convection currents, the engine inside the Earth that drives plate tectonics of the crust are from convection currents from Earth's mantle. So technically, this means that earthquakes, volcanoes, most of Earth's volcanoes and earthquakes occur at the plate boundaries as they interact. Then this causes the plates to usually move. Then there's fault movement. Fault movement is the crack in Earth's crust that moves. So, for an example, a rock that cracks in an Earth every time, that is called the fault movement. And that's it for my video, and thank you for watching.